Somewhere, in the vast unbroken silence of deep space, the James Webb Space Telescope captured something it was never meant to find. A flicker. A distortion. A pattern so precise, so mathematically perfect, it defied all expectations. It shouldn't exist. And yet, there it was, etched into the background radiation of a galaxy cluster billions of light-years away. Scientists stared at the image in disbelief. This wasn't just cosmic noise. It was a fingerprint of something far beyond our understanding. Google's most advanced quantum computing team took one look at the data and confirmed the impossible. What you're about to discover could change everything we thought we knew about the universe, and reality itself. It all began with what was supposed to be a standard observation. The James Webb Space Telescope was scanning Able 2744, also known as Pandora's Cluster, a densely packed field of galaxies, perfect for lensing studies and detecting some of the oldest light in the universe. But within the sea of distant starlight, the Webb team began noticing something strange. It wasn't a missing star or a broken signal. It was a distortion, a diffraction pattern that didn't behave according to known laws of physics. Most light curves under gravity, especially when passing near massive galactic bodies. But this was different. The distortion appeared ordered, symmetrical. It didn't fade with distance. And most alarmingly, it repeated in places where it shouldn't have. Initially dismissed as a software or imaging artifact, the anomaly persisted through every calibration run, through multiple filters, and even with different time exposures. Even when the telescope refocused, the anomaly remained embedded in the data. Something out there wasn't just bending light, it was encoding something in it. That's when NASA turned to a new kind of interpreter. Not a person, not a classical algorithm, but a quantum system designed to find patterns where human logic couldn't. And that's when Google's quantum computing division entered the story. And everything changed. Google's quantum AI team wasn't brought in to search for aliens. They were tasked with decoding high-dimensional noise patterns buried deep within light signatures that traditional systems couldn't process. Their quantum computer, Sycamore, operated using entangled qubits, allowing it to consider every possible outcome simultaneously, rather than one solution at a time like a normal supercomputer. The raw Webb data was fed into Sycamore, and it ran for days. When it returned its results, even the most skeptical physicists were stunned. The quantum system had isolated a non-random pattern, one that matched theoretical predictions from string theory, the existence of hidden dimensions. According to these models, gravity might be weaker than other forces because it leaks into extra-spatial dimensions, places beyond the three we can perceive. And the distortions in Webb's light weren't just gravitational lensing. They were visible side effects of this leakage, affecting photons as they traveled billions of light-years through folded, vibrating space. It was as if something outside our dimensional frame pressed its hand into the fabric of the universe and left a fingerprint of its structure behind. And that fingerprint mathematically aligned with brain world models, the same concepts once dismissed as speculative fantasy. Webb had unknowingly captured not just galaxies, but a glimpse of how the universe might truly be constructed from the outside in. For over a century, gravity has been the great outlier in physics. It's the weakest of the fundamental forces, billions of times weaker than electromagnetism or the nuclear forces, and no one has ever truly understood why. But the new Webb data and its quantum analysis might offer an answer more radical than anyone anticipated. According to emerging interpretations, what Webb captured wasn't just gravitational lensing through space. It was gravitational bleeding into adjacent dimensions. Imagine our universe as a thin film, like the surface of a bubble. If gravity can flow into higher dimensions, it would weaken in our own. But in certain conditions, when the structure of those dimensions fluctuates or aligns, their presence could warp light, just as was observed. This means that dark matter and dark energy, those mysterious forces we've labeled out of ignorance, might not be things at all. They could be side effects, echoes, projections of forces originating in a greater dimensional framework. And for the first time in history, we may have seen that framework imprinted onto a photo from a telescope floating 1.5 million kilometers from Earth. It's no longer just a matter of philosophical debate. It's data, hard data. And while some scientists remain cautious, others are already speaking of a paradigm shift. Because if our universe is just one membrane in a higher dimensional space, we're no longer asking, what's out there? We're asking, what's beyond here? There's a cruel irony in all of this. The galaxy field where Webb first detected this anomaly, where it was targeting Pandora's cluster, now seems to live up to its name more than anyone could have imagined. With that single image, accidental, routine, unintentional, we may have opened a door no one meant to knock on. The idea that our universe is part of a larger, more complex superstructure isn't just a fringe theory anymore. With every reanalysis of Webb's data, the quantum patterns become clearer. Peer-reviewed papers are flooding journals. Research labs at MIT, Caltech, and CERN are shifting their focus. And behind closed doors, defense agencies are reportedly examining the implications of higher dimensional space, not as science fiction, but as a framework for understanding reality itself. But there's fear, too. What if what we're seeing is just the edge? What if these diffraction patterns are the signature of something else, watching back from outside our dimensions, from outside our rules? Because for all its power, Webb wasn't designed to look into other realms. Yet, it might have accidentally done so, silently, without anyone realizing it until now. And in doing so, we may have peered behind the curtain of spacetime, only to discover that we're not alone, not in the way we imagined, but in a way we may never fully understand. For centuries, science has operated under the assumption that the universe is governed by fixed, predictable laws, that light bends under gravity, that time moves in one direction, and that matter occupies space. But what the James Webb Telescope may have captured calls all of that into question. The recurring diffraction patterns hidden within the galaxy cluster imagery don't just hint at extra dimensions. They suggest that our known framework of spacetime is incomplete. It's not just that there may be higher dimensions. It's that they may be interacting with ours right now, at every moment, shaping the behavior of matter and light in ways we've never imagined. Astrophysicists are now facing a chilling realization. Our cosmic map, built from centuries of Newtonian mechanics, Einstein's relativity, and quantum field theory, might only be the beginning. It might be nothing more than a two-dimensional sketch of a four-dimensional landscape. The James Webb Space Telescope didn't just capture a new image, it tore a hole in the map itself. And as every great explorer knows, when the map no longer matches the territory, you've just entered the unknown. One of the most deeply held truths in physics has always been that nothing travels faster than light. It's the universal speed limit, the rule that keeps causality intact and ensures time flows forward. But according to some interpretations of the new Webb data, that rule may not be as universal as we thought. When light is observed through gravitational lensing, we expect distortions. But the distortions captured in the Able 2744 images are asymmetrical, irregular, and inconsistent with what we understand from general relativity. Some quantum physicists now suggest that what we're seeing isn't light bending, it's light slipping, moving through regions of spacetime where the structure allows it to accelerate via geometric shortcuts. If that's true, the idea of a multiverse, of quantum tunneling across branes of reality, of the universe not being flat but folded, becomes more than science fiction. It becomes mathematically plausible. And suddenly, what we've called light speed is no longer the limit of motion, but the limit of our perception. James Webb may have shown us that we're not just trapped in three dimensions. We're trapped inside a misunderstanding of what dimensions even are. While scientists scramble to verify and replicate Webb's findings, the philosophical shockwave has already begun to spread across the globe. Universities are rewriting curriculums. Thinkers are re-examining the very fundamentals of consciousness, time, and existence. Some have compared this moment to the Copernican revolution, when we learned we weren't the center of the universe. But this is bigger. Because now, we're not just questioning our place in the universe, we're questioning whether we're even in the right universe at all. Cultural leaders, philosophers, even theologians are now entering the conversation. What does it mean if our reality isn't the base layer of existence? Are we the cosmic mainframe, or just one simulation in an endless cascade of nested realities? And if higher dimensions are active and structured, what role do we play in them? Are we blind passengers or accidental observers? These are no longer questions from science fiction novels. They're being debated in academic halls, government panels, and late-night newsrooms. And it all began with one image. Just one, from a telescope that was never built to find anything like this. Perhaps the most poetic part of all this is that the James Webb Space Telescope, an instrument designed to study the first stars and galaxies, has accidentally stumbled onto something far more profound. It was built with rigid parameters, trained to capture light in the infrared spectrum, optimized for predictable cosmic structures. And yet, through its sheer sensitivity and precision, it became a rebel, a machine that, in following its programming flawlessly, broke free from its design. Webb didn't discover alien life. It didn't find a wormhole. But it may have done something even more revolutionary. It forced humanity to reconsider the canvas itself, the structure beneath space, the rhythm beneath time, the very fabric that holds our reality in place. And it did it silently, without flashing lights or dramatic signals, just pure data. Cold, mathematical, unmistakable. The kind of data that rewrites textbooks, not one page at a time, but from the cover inward. And now the world watches as physicists, philosophers, and dreamers alike race to answer a question we never expected to ask this soon. What did the universe just show us? And what do we do now that we've seen it? We built the James Webb Space Telescope to answer questions about our past, to see the first light of the universe, to understand how galaxies formed, how stars died, and how planets were born. But in doing so, we may have uncovered something we never expected, a crack in the mirror of reality itself. The images we captured weren't just beautiful. They were impossible. They didn't just reveal galaxies and nebulae. They revealed fingerprints, subtle, precise, recursive patterns that may belong to structures far beyond our comprehension. Extra dimensions. Hidden frameworks. Forces that don't belong to our three-dimensional logic. Webb didn't just show us the universe. It revealed that what we thought was reality might only be a layer of something far more complex. And the most haunting part? It didn't come with a warning. There was no alien signal. No dramatic soundtrack. Just silence. Just numbers. Just light twisted in a way we never expected, whispering truths we're only just beginning to translate. Now we stand at the edge of something vast, terrifying, and beautiful, not because we found aliens, but because for the first time we might be seeing the threads behind the curtain, the architecture of existence. And we didn't stumble upon it through war or conquest, but with a telescope floating silently in space, doing exactly what it was built to do. The question is no longer, what's out there? It's, what's behind everything we thought we knew? And the world may never look at the stars the same way again. Do you think what James Webb found is just the beginning? Are we truly on the verge of uncovering the hidden structure of the universe, or are we simply staring into a cosmic illusion? Let us know your thoughts in the comments. And if this left you in awe, subscribe and turn on the bell, because this journey through light, time, and truth is only just beginning.